Hey everyone, notes 4.8 are on modeling with sinusoidal functions. And in this first example, it says that Canada's Wonderland has a Ferris wheel with a radius of 10 meters, and it takes 6 minutes to complete one revolution. To board this ride, you must step up 2 meters. So the first question says to draw a graph to represent how a person's height above the ground varies with time. Note that the Ferris wheel rotates counterclockwise. So, it says right here that to board this ride, you must step up 2 meters. So that means that this right here is going to be 2 meters. Okay. It also tells us that the radius of the Ferris wheel is 10 meters, which means that this would be 10 or that this would be 10. Okay. Which brings us to a height of, like our maximum height that we have right here is going to be 2 plus 10 plus 10, or 22 meters. Okay. Okay. So before we do our graph, I actually want to define variables for the problem. So it says that we want to draw a graph to represent how a person's height above the ground varies with time. So the height depends on the time, which means that time is your independent variable. And because it's independent, it should be the x value. So we're going to say let x represent time. And this time is going to be in minutes because we know that it takes 6 minutes to complete one full revolution. And then we'll say let y represent the height in meters. So I wanted to define that first because the time in minutes needs to be labeled on the axis, and then the height in meters also needs to be labeled on the y-axis. Okay, so we know that the minimum height is going to be 2. So if you look right here, we know we are going to have a minimum height of 2. We know that our maximum height is going to be 22. So right here, we'll say that this is 22. We also know that our axis is going to have to occur 2 plus 10, which is 12, or 22 minus 10, which is also 12, which means that we will have an amplitude of 10, okay? And we know our amplitude is 10 because the amplitude represents our radius right here. That's really important that we note that down. We also know that you're going to board the ride at time 0, okay? And then it says that it takes 6 minutes to complete one revolution. So this tells us that our period is going to be 6 minutes. So we're going to complete one full rotation all the way around in 6 minutes. So we're going to start at our min of 2. And we know that after 6 minutes, we will be back at our min again. I'm actually going to draw on a line to represent the min, the max, and the axis. Okay. And we know that after 6 minutes, we're going to hit the min again. So here we are back at the min again. Now we also know that the next time, if we start at the min right here, we know that it's going to hit the axis after one critical interval. So we need to calculate a critical interval based on the fact that our period is 6. So our critical interval is going to be 6, which is our period, and divide that by 4, because remember, our critical interval is going to be our period divided by 4, which is 1.5. So if you look right here, we're going to have 1.5 minutes, 3 minutes, 4.5 minutes. So if you can see right here, we know that it's going to hit the min at the beginning, and then after 1.5 minutes, we're going to hit the axis. And then after another 1.5 minutes, or at 3 minutes, it's going to hit the max. And then another 1.5 minutes, or at 4.5 minutes total, it's going to hit the axis and then the min. And then we can kind of show that again. So another critical interval would be 1.5. So that would bring us to 7.5. Another would bring us to 9. Another would bring us to 10.5. And then lastly, we are at 12. And we're just going to do it all over again. So this is kind of a sketch of what's happening here. Now, just a reminder that our amplitude is 10, and that represents the radius of the wheel. Okay, so next it asks us to determine equations for a person's height starting from the bottom of the Ferris wheel. Express your equation in terms of both sine and cosine. Well, in order for us to be able to do that, we need to identify some key pieces of information. We've already figured out that our amplitude is going to be 10. Like we know that from this piece of information here. So we know we have an A value of 10. We also know that our C value is going to be 12 right here. How do we know that our C value is going to be 12? Because we figured that out by looking and seeing that this value right here is 10 above the minimum or 10 below the maximum. Okay, and you can also just average the min and the max as well. And just a heads up that this represents the height of the axle. The axle is going to just be like the center part of our Ferris wheel, okay? All right, now we need to figure out the K value. And just a reminder that the K value is always going to be equal to 360 divided by the period. And we know that the period is going to be 6 minutes. So to find the K value here, we're going to do 360 divided by 6. So our K value is going to be 60. And also just a reminder that our D value is going to depend on the type of graph that we're going to use. Whether we're going to use sine or cosine. So let's go ahead and start with the easiest possible thing. In my opinion, I think our easiest option right now is to just start with cosine, because if you look right here, cosine starts either at the min or the max. A positive cosine starts at the max, a negative cosine starts at the min. Because this graph already starts at the min, I can use a negative cosine. So if I'm going to use a negative cosine, then our phase shift is just going to be 0 because we haven't moved it at all. It is literally starting at 0 on the min, and that's where negative cosine will start. So based on that, we can just say our equation is going to be y equals a, which is 10. However, because it's a negative cosine, it's going to be negative 10 times the cosine of, and then the K value is 60, times x minus d, which is just x minus 0, but we don't have to put this minus 0, and then plus c, which is 12. So here's one equation that we could get. Now, let's talk about sine. If I want to use sine, remember, sine always starts on the axis. And if I'm going to start on the axis, I can either start here or here or here or here. It really doesn't matter. I've got infinite options. But if I were to start here, this is going to be one critical interval away from the starting point. So if I were to use this as my starting point, then the D value would have to be 1.5. I'm going to erase this, by the way, because I'm going to need some space here for later on. So if our D value is going to be 1.5 right here, and this is going to be a positive sign because it starts on the axis and goes up to the max. If I use this, then it would be a negative sign. It starts on the axis and goes down to the min. So sine right here, if I use this, then the D value would be 1.5. And this would be a positive sign because, again, it starts on the axis and goes to the max. So because it's positive sign, the A value will be 10. We'll say the absolute value of A is 10 over here. And then we're going to say the sine of, and then we'll put here 60 times x minus d, which is 1.5. And then we'll say our plus 12 right at the end. Now, just a reminder that you can also say that this is just going to be y equals 10 times the sine of 60x minus 90 plus 12. Either one of these works. Okay? Your job right now is to pause and try to get a positive cosine equation and a negative sine equation. Okay, so I need you to do that, and we'll take it up next time I see you in class. Okay, question D says, what's the height of the rider after 20 minutes? Well, 20 minutes, if we're talking about minutes, this is our time, and X is time. So this pretty much means that I have to sub in X equals 20 into any equation we want. So I'm going to use the negative cosine equation because there is no D value. It's nice and easy. Okay, so every time I see an X, I'm going to sub in 20. So this is 60 times 20, and then plus 12. And 60 times 20 is 1200. And then I can figure out what this is as a value, cosine of 1200. And we know that the cosine of 1200 is negative 0.5. So we're going to say that this is negative 1/2, and then we'll evaluate from there. But if you notice, this is a special triangle value. So I want you to think about how would we figure out what this answer is without a calculator. I want you to think of coterminal angles, related acute angles, the different quadrants we're in. I want you to figure out all that stuff. How can we figure that out without a calculator? And we're going to discuss it next time I see you guys in class. So make sure you actually think about this, please. Okay, so the negative 10 times negative 1/2 is 5, and then 5 plus 12 is 17. So the height of the rider will be 17 meters after 20 minutes. And then I'll ask you guys to write a therefore statement. But you guys can do that on your own. Okay, so for this last question, you're going to want to write small because unfortunately we don't have that much space for the question, but there's a lot of stuff that we have to do. So it says, in the first 6 minutes, when is the height 16 meters? So essentially what we want to do here is we want to figure out when is the height or the y value equal to 16. So we're going to sub this in. And again, you can use any equation you want. I will use the cosine, the negative cosine one just to make my life easier because this is just 60 cosine of x. It's a lot easier to deal with. Plus 12. So I'm going to sub in 16 right here. And then I'm going to say equals negative 10 times the cosine of 60x and then plus 12. Then I'm going to get rid of the 12 from the 16 right here, and I would end up getting 4. So 4 equals negative 10 times the cosine of 60x plus, and then the plus 12 is gone, so I don't have to write anything there. I'm just going to highlight that I got rid of this 12 right here. Then I'm going to get rid of this negative 10 right here by dividing everything by negative 10. So I get 4 over negative 10 is equal to the cosine of 60x. But I'm going to reduce this to negative 2/5 and then just copy this down. Now this 60x makes things really difficult for us. We don't really love this 60x right here. So we're going to do a substitution and we're going to let u equal 60x to make this so much easier for us to deal with. So if I do that, then this is now going to say negative 2 over 5 equals the cosine of u instead of the cosine of 60x. This again is going to make life easier for us. Well, don't forget that we have to find our related acute angle first. This is really important. So in order for us to be able to find a related acute angle, we need to use the positive version of this ratio right here. So we're going to say 2 over 5 is equal to cosine of u sub r because we're finding a related acute angle. And then to solve right here, I'm going to say that u sub r is equal to the inverse cosine of 2 over 5. First of all, make sure that your calculator is in degree mode. Okay, and I'm going to do the inverse cosine of 2 over 5. Now, this is my related acute angle right here. So I'm going to just store this into my calculators like A for like alpha, or related acute angle. It really doesn't matter. I'm just going to store it in as any variable I want just to make my life easier. So I'll do alpha A, press enter. Now, this is my related acute angle. However, I need to figure out what my actual U value is going to be. So remember, cosine is negative in quadrant 2 and quadrant 3. So we'll find our first answer in quadrant 2. So our first answer for U sub 1 is going to be 180 minus our related acute angle, which I forgot to write down, is approximately 66 degrees. Okay, so that means that U sub 1 is 180 minus our related acute angle, because this right here is our related acute angle right here. Okay, so this is going to be 180 minus U sub r. So I can go into my calculator and do 180 minus U sub r, which is alpha A in my calculator, and this is going to be approximately 114 degrees. I want to use the value in my calculator and not an approximate answer. But we do know that we can write this down as U sub 1 is equal to approximately 114 degrees. Again, we're not going to use 114. We're going to use the calculator, the value that's stored in our calculator. Now, if U is 60x, our goal is not to solve for U, our goal is to solve for x. So if U is 60x, then I have to solve for x, I have to divide by 60. So I'm going to do U equals 60 is U over 60 equals x. Just isolating for x, okay? So that means that x1 is going to be equal to u1 over 60. But we figured out that u1 is 180 minus u sub r. So I would figure out what this value is in my calculator by taking the 180 minus u sub r, which we already just figured out right here with this value right here, which is this 113. I can just take that answer, divide that by 60, and we know that it's going to be approximately 1.89 minutes. So we know that within the first 6 minutes, the height is going to be 16 meters at 1.89 minutes approximately. Now, let's take a look at our graph and see if that makes sense. So if it has a height of 16 meters, if you take a look right here, this height of 16 meters is going to occur at approximately 1.89 minutes. That should make sense to you, that it's approximately 1.89 minutes. The question's asking us to determine when within the first 6 minutes, this entire time that we have right here, is the graph going to be, or is the Ferris wheel going to have a height of 16 meters? So we have a second answer right here at this point right here as well. Now there's two different ways that we can figure out what this answer is. The first way that we can figure it out is kind of just logic our way through this. If we know that this is 1.89 minutes from the start of a cycle, then this value right here must be 1.89 minutes from the end of a cycle, because this is symmetric. So we could just say this is 6 minus 1.89 minutes, which is going to be approximately, I'll type into my calculator, 6 minus, and then I'm going to do second answer, because that's going to give me my answer right here. So this is going to be approximately 4.11 minutes. Okay, hopefully that makes sense. That's one way you can figure it out. The other way you can figure it out is you can use the fact that you know your related acute angle, because cosine is not negative just in quadrant 2, but it's also negative in quadrant 3. So we know that we figured out our related acute angle. So if we want to find our second answer, it would be 180 plus our related acute angle. And so U2 would be approximately 180 plus what we got for a related acute angle, which we stored in as A, or 66 degrees, right? That's what we got right up here, that our A value, or our related acute angle, is 66 degrees. So if I add that together, I get approximately 246 degrees. Remember that we are going to use our answer from our calculator, not an approximate answer. But again, I want to figure out what x2 is, not what u2 is. So I'm going to use this equation where we've isolated the x. So we're going to say that this is u2 over 60, but we know that u2 is 180 plus u sub r. So this is going to be approximately, let's figure this out, divide this by 60, and we get approximately 4.11, the exact same answer that we got up at the top, okay? I want you to really take your time with question E, go through it, double check, make sure you understand all the work, try to make sense of it. If you have questions, let me know, but make sure that you make sense of it first. You try your best to do what you can to make sense of it, and then I'll help you out when I see you in class. We will do the back page when I see you guys in class as well. All right, have a good day. Bye.